Okay, let's try to do a comparison test on this one. So thinking on the right-hand side, thinking. This is going to be similar to just 1 over e to the n, which you can write like that. When n is large, n large. Okay, but then I have to think about what is the connection? What is the inequality between these two? Well, I am first of all going to say, well, summation 1 over e to the n is convergent since r is equal to 1 over e, which is less than 1. So this guy is convergent. So if I want to use comparison test to prove that something is convergent, then I better find something bigger that is convergent. But unfortunately, in this case, the inequality goes the other way here. That's quite unfortunate for a comparison test. So this is useless for comparison test. Okay, if I want this to be useful, I would need the inequality to go the other way. Okay, so what am I going to do instead? Well, what I'm going to do instead is I'm going to use what's called the limit comparison test. So if an is bigger than 0 and bn is bigger than 0, and you look at the limits of the quotient. So look at the limit of the quotient, and imagine you get a number L, where L is between 0 and infinity strictly. So if you take this limit and you get a number between 0 and infinity strictly, then you can conclude that sigma an and sigma bn have the same, let's say, behavior. They either both converge or they both diverge. Okay, so for our example, an is the given thing here. Now, bn, I'm going to get from this idea here. Okay, so what bn is bn is a kind of a simpler sequence that is similar to an when n is large. So I'll use my limit comparison test. So I'll calculate this limit. Okay, of course, n is going to infinity. And so what do you get? Well, limit over, oh, that's too big. I start with the big one, 1 over en minus 1, 1 over en. Lim, okay, so flip and multiply, you get e to the n over the e to the n minus 1, which is equal to, so at this point in the course, I'll allow you to do what's called, dropping non-dominant terms. So we drop the non-dominant terms. Oops. Then we get 1. So L is equal to 1, and that is certainly between 0 and infinity. Okay, so we can use the limit comparison test. So we calculated this L. It is between 0 and infinity. So these two series have the same behavior. They either both converge or they both diverge. But in my thinking that I did earlier, up here, I know that summation bn is convergent. So I know that summation bn is convergent. It's geometric, convergent geometric. And I know that summation an and summation bn have the same behavior. So put that together and you conclude that summation an must be convergent as well. So I'm going to write this out completely. So I know summation bn is convergent, because r is less than 1 in absolute value. It's geometric. So summation an is convergent by the limit comparison test. And in the future, I'll use an acronym LCT. Okay, so to review this example, what did I do? Summation an. So I said an is going to behave like bn when n is large. So that tells me that bn is a good choice when I go and do this limit here. I do the limit, I get 1. Limit comparison test says, okay, because I got something between 0 and infinity there, then sigma AN and sigma BN must have the same behavior. But, if I look up here, bring a star there, I know that sigma BN is convergent. So I conclude that sigma AN is also convergent.